Materials Interest Group session. I would like to let you know that we are going to be recording the meeting today. So if there are any objections to that, either don't turn on your camera, or if you want to leave the meeting, that's fine also, but we will be recording it and posting it to the AATCC website for members that have registered afterwards to view. And some housekeeping notes for our meeting today. This is your opportunity to ask questions and have your opinions heard. If you have questions, comments, opinions, please post them in the chat. I will be going through and moderating the questions and asking our presenters today. You can also raise your hand as well if there's something that you would like to ask specifically or directly. And like I said, please mute your conversation until you have a question to ask, and list it in the comments section. And next slide. So today we are pleased to welcome Matt Gande and Anu Gupta from Keel Labs, who will be talking about their algae-based fiber, Kelsun. So Matt Gande is the lead scientist of fibers and polymers at Keel Labs. He's currently leading the technical efforts to transform the idea of using a sustainable algae-based fiber for apparel applications into a commercial reality. Anu Gupta is most recently from NC State University, where she focused on natural fiber-based composites, and has recently joined the Keel Labs team to focus on commercializing algae fiber. So without further ado, I'm going to turn it over to our two presenters today to let us know all about Kelsun fiber from Keel Labs. Welcome. Thank you very much.
Thank you. Let me pull up the presentation, which, how do I do that? Share. Can you pull it up? Because I can't quite figure out how to do it.
In the top row next to the red button, there's a share button with an arrow.
Yeah.
You should be able to click that and share your screen.
Okay, how do I share screen? Oh, never mind. There we go. The screen had your picture, so I was a little confused here. Sorry.
We've got it.
This is Matthew Gande. I've been with Keel Labs now for almost 5 years. Brought in as the technical fiber and polymer scientist. I'm going to share this with Anu. I'll let her introduce herself and start off.
Yeah, hi everyone. This is Anu, Anuradha Gupta. Been with Keel Lab for almost a year now. Joined as a senior scientist and now currently in a senior manager at R&D, working very closely with Matt on the research and development side at Keel Labs. Very excited to be here. A little bit of my background. Obviously, so before I started with Keel Labs, I was with various other textile companies before this, and before that, I graduated from NC State with a textile PhD. That was in 2019, so quite some time. Have been with the textile industry for more than 4 years now. But before that, I had background in finance and marketing on the business side. So technology was something new for me and very exciting for me at this time. But being in textile side, something which really stuck my head was the sustainability part, and that's why I researched on that aspect too. So my research was on the natural fiber composite, where I used hemp. So that's where the sustainability started from my side. But working on the textile, one thing I realized that textile is a major contributor of carbon emission, and it's getting worse every year. as per one of the study, the fashion industry is on track to contribute up to 25% of the world's carbon emission by 2025. And right now we are at 10%, but if it goes unchecked, it can go as high as 25%. So that is kind of alarming. The fashion industry represents one of the important economy in our country, and with so much development going on, definitely the impact will be widespread. So how do we change that? So how can we make it better? So Keel Labs is working towards the sustainability goals, where we are a material company addressing the high polluting system of textile production based on our material completely based on the ocean material, which is very untapped market. Algae-net has been in the in this for a long time, but not in the textile application as much. So we are working towards using the seaweed, algae-net in the textile landscape, and understanding how to modify and get how to modify the and to apply it in the textile world. So we all know that seaweed grows in abundance in the wild and in the seaweed farm, but how to take advantage of these regenerative resource and use it in more towards the sustainability way. And Matt will be going into more details in all of these areas. So sustainability, as we know, is no more a luxury, it's a requirement. It's a requirement for everyone who comes or represent the textile industry, fashion industry. So just to put it simple way, there is definitely a call for action, which is urgent in order to eliminate, not necessarily eliminate, but to do more of like a damage control and slow down the progression of carbon emission contribution. It will just give us a longer runway and to come out with more solution and to these problems. Next slide, please. Thank you. So that's where our calcium fiber comes into play. Our calcium fiber is a seaweed based and has a significantly low environmental footprint than any other conventional fiber. So firstly, it's like regenerative organism in our planet, and it grows in abundance. We all are aware that whenever we go to the beach, we see seaweeds lying everywhere. So how to utilize those byproducts of the sea, so to say, in a more effective way? So we create calcineon using these seaweeds and mostly on the biopolymer side, and then harness the renewable power of the marine ecosystem. So we pair the biopolymers with our green chemistry and then apply it into the existing textile world. So the end product of is calcin, which is a bio-based, and it can be used in the textile industry. So our solution is simple. If we use climate positive raw material, which is kelp and seaweed, we use use very clean chemistry, which is very less toxic, which is traditionally been the case, and provide a drop-in solution where we are using an existing traditional textile production infrastructure to convert into yarn for apparel application. And Matt will dive into all of these areas separately during his section. So before we move to the more on the process side, what we do at Keel Lab, I would like to reiterate what we really value. Definitely we value planet, people, and prosperity. So planet being, we definitely want to use a regenerative resource, cut down the water usage, which has been abundant in the textile industry, and reduce the carbon emission. From the people side, definitely use as less of hazardous chemical, make it as less toxic as possible, and so that it takes care of the water problem, as well as it also caters to the soil degradation and microplastic pollution, which is also getting widespread now in this area. And then definitely prosperity. So tapping into those market section where people are looking for more of a sustainable alternative, and And that's how we improve our manufacturing process as well. Next slide, please. So we'll talk about the process of converting and from how do we convert seaweed to apparel, and Matt will talk about each section separately, starting with seaweed as a biopolymer, what is the process we go into, and then how we convert it into textiles. So Matt, over to you.
Sure. So I'll start off. This is the whole soup to nuts image here. As you can see, Keel Labs is really focused on sort of this middle section, but I want to start from the beginning, the biopolymers, or the seaweed aspect of, keep on going 2 slides. Oh, that works. The button wasn't working before. So white kelp, Anu has talked a bit about this. This is one of the fastest growing organisms. It can grow, multiple, tens of meters in a day, and sometimes, not a day, but
over time.
Over time, but very quick. Also, there's a wide variety of seaweeds out there, and each brings something a little different to the table. So one of the things, because it's so fast growing,
inside of real.
Excuse me. Was there a question? Okay. Since it's so fast growing, it consumes a lot of carbon dioxide, and that can actually reduce the acid acidification in the local environment around that seaweed, because it's such a good absorber of CO2. One of the big features that we like about it, it doesn't compete for land use for food crops even. So it's taking away some of the demand on arable land. It also doesn't require fresh water, so all the water issues that go along with plant growth is no longer concerned about here. It just grows in typical salt water situations. In places where there is agricultural runoff, algae and kelp are known to help clean up the water there, remove some of that nutrients from it. And the other thing, as Anu said, people is one of the focus that we have. This actually provides a revenue stream for a lot of coastal communities, often in off seasons for fishing communities. So it gives them something to work when they can't be out fishing. So how is the seaweed or kelp collected? There are several ways this can be done. If you look at the sargassum image there, you can see a lot of seaweed on the shore, on the beach. And as Anu had said, that whenever we go to the beach, sometimes you can see a lot of that seaweed. It can be a real problem. It can be collected right off the beach in some cases, depending on which seaweed we're looking at. So that's one source of collection. Other is just harvesting wild-grown seaweed. So going out to where it's being grown and collecting it from there. Both those modes, either collecting off the beach or collecting wild-grown material, there is regulation in place to prevent over-farming of the seaweed, because you can imagine if you collect all that's there, the natural environment has changed quite a bit. The other way is actually to farm the seaweed. Lots of times lines are just put in the water for the seaweed to grow on it. So that's a lot more controlled. We can control, or it can be controlled where the farms are, and often these farms are in combination with fish farming as well, because it gives a place for the fish to grow around. So there can be some mixing of different product lines, if you will. So that's the seaweed. And you can see here, there are different species grown around the world. Tends to be in the more temperate or cooler climates. You can see in north and south of the globe. There is some in the equatorial belt, but most of it is cold water seaweed that we're looking at here. And it's very well distributed throughout the world. So any place where where we would be considering setting up a plant, could be a natural source of seaweed close by. So unlike things like cotton, where the fiber is actually what's harvested, you have the fiber built into the structure. There's no fibrous material in this kelp that we pull out, similar to hemp or cotton. What we need to do is extract the active biopolymer that's in there that we're looking at, which is an alginate, or it's based on alginic acid. This is done by taking the seaweed. It's usually dried seaweed for easy transportation, and that's soaked in a low concentration hydrochloric acid solution to break up some of the physical structures and convert any of the alginic acid salts that are in there back to alginic acid. This material is insoluble in water, so any water-soluble impurities that are there can now be removed by simple filtration and collecting the solid mass that's left over. To extract our material, we then add a sodium carbonate base to the solution that then reacts with the alginic acid that's in there and forms sodium alginate. Sodium alginate is very water soluble, so once we've converted to the sodium alginate, it's now in solution, and we can filter off the rest of the biomass from the kelp and remove that, and we'll have a solution of sodium alginate in water. So again, all this is aqueous processes that we're talking about here. And then there are three major pathways for actually isolating sodium alginate from that. One is simply using ethanol to you add ethanol to the water solution. That ethanol is non-solvent for the sodium alginate, and that just precipitates out of solution and can be isolated that way. There's an HCl route where it actually goes through re-acidification to alginic acid and allowing another wash step to occur to purify it, and then bringing it up into sodium alginate and isolating that. And a third pathway, which allows even further purification to occur, is this calcium chloride pathway, where it's first precipitated as calcium alginate. And again, that can be cleaned up, and once that's done, it's re-acidified to alginic acid, formed, and again, another step for cleaning the material, forming the alginic acid from that, and then making it into the sodium alginate and isolating it. So there are several different pathways that can be done in order to isolate sodium alginate from the kelp. So I've been talking about sodium alginate. What is alginate? It's actually a polysaccharide. It's a linear chain of sugar units. These sugar units are either hyaluronic acid or mannuronic acid, and you can see, looking at the structures here, they are very similar in structure. That the only real difference is the stereochemistry around the carboxylate group. Excuse me. These can be actually polymerized, or the polymers formed by either forming blocks of the mannuronic acid, as you can see here in red, or G block material where you have multiple hyaluronic acids combined. And finally, there's some in these polymer backbones of these Mg, so you get the mixed alternating units in there. The big difference between these different blocks, again, they have all got very similar monomer units. The M block is fairly linear, has a reasonable amount of flexibility in it, whereas if you look at the G block, you've got this cup-shaped material. It's a little more rigid in structure. So if you look at this, the amount of M and G block in a polymer, the more G there is in it, the more rigid the structure is. The other thing with that G block is how it can interact with multivalent ions. I talked earlier about precipitating in the purifications, that precipitating out as calcium alginate. You can see when calcium reacts with these, it can actually fit into that cup the G blocks, and actually these two G blocks can come together and sort of cage that calcium. This is called you'll see this cross linking called the egg box model, where the alginate acts as the egg box, and you got calcium egg in the middle, holding two chains together. And by doing that, you're now cross-linking these polysaccharide molecules together, and that's what makes it insoluble, as I said, for the precipitation part, but it's also critical in forming fibrous material from the alginate, is these ionic crosslinks that can be formed in the backbone of the material. As I said, the G blocks and M blocks can, how they're in there can affect some of the physical properties that are there. And those G blocks, M blocks are built in during the production or during the biosynthesis of the alginate within the kelp. And you can see here, there's a lot of different species of kelp. I'm not going to try to pronounce most of these. But you can see, for example, the Lawsonia has a fairly high G content to it. So there'll be a lot more of those cross links that can occur in a Lawsonia versus something like this first one here, has a low G content. That Mg ratio can also vary, not just by species, but by season. You can see here on the chart on the right-hand side, depending on what season of the year, some of these kelp plants have a very different Mg ratio. So all this leads into some variety in the source of alginate that you use for this process.
And something to point out that, this ratio of M and G is also varies from different areas which we source seaweed from. So it will be different what we get from, say, South America, for example, and that would be different for Asia as well. So through different geographies, it will also change.
Right. And also something I didn't point out earlier, within the kelp itself, the amount of alginate that's in there can vary a fair amount, but it's a substantial proportion. You can see here in this middle chart, we're seeing yields of sodium alginate from the kelp anywhere from 25 up to about 45% of the mass. So it's a pretty high, rich source of raw materials. Okay, so that's the raw materials for our process. Now I'm going to talk a little bit more about our process. The first thing we need to do is take the sodium alginate and put it in a form that we can use. We dissolve it in water to make a solution of the material. And at this point, we can add any additives we want to into that solution. So if there's anything that needs to be done to modify the properties we get, this is one area where that can be done. Once it's in solution, the solution we also call a dope. So that is then extruded. So we use usually there's some sort of metering pump that allows a very careful control of how much material that you're extruding, and that goes into a spinneret to make multiple filaments, and there can be anywhere from 1 to several thousand filaments within a spinneret that we're talking about here. That goes into our coagulation bath, and within that bath is a mineral salt that will do that coagulation that we talked about earlier. So it's taking this water-soluble solution of sodium alginate and then coagulating it as a solid material in these filaments that come through a coagulation bath. Once that's happened, we can wash it to remove any excess salts from the system and draw it to control some of the physical properties of the ultimate fiber that we're making. And then this goes through a drying process because we start off with water and the dope. We need to remove that to just have the solid material left behind. and then that can be wound onto a spindle spool. If anybody's familiar with the viscose process, you can see a lot of similarities here. And as Anu said earlier, how we're always looking at being able to use existing technologies. This, while not exactly like that viscose process, has enough similarities that that with some modifications can be used in a typical viscose situation. So depending on the end use application, that filament tow that we made could actually go into a filament yarn. Our focus is more on being able to blend with other materials. So we want to make this into a staple fiber, so that filament yarn can easily be texturized through a number of different methods, such as a gear crimper or stuffer box or anything that will give some texture to it, so it'll spin well in the final process, and then cut to the appropriate length depending on what we want to blend it with, or even if we're going to use it alone, what length we want for that. Once it's cut into staple fiber, we can then blend it with other fibers, cotton being one that can be used. We've looked, you can look at other fibers as well. Our focus is obviously on natural fibers. There's nothing that would prevent you from blending this with synthetic fiber like a polyester, but that gets us away from our main focus. But yeah, it can be blended with whatever is we're interested in. Once it's blended, we can card it, and then through the standard ring spinning process, form the sliver, draw that down, make roving, and then ring spin into a final a spun yarn. And again, we can make various weights of yarn with this, and at this point, it can be then, in theory, this is the end of the Kelsen part of the process, and now we go from the yarn that we've made onto final garments and products and textiles. So I'll let Anu take over from here on that part.
Thank you, Matt. So talking on the end product, which will be our textile. So as Matt pointed out already, that we can blend with any kind of staple yarn or filament yarn, and then weave or knit based on what the application is to different different structure of weaving, different kind of knitting. So it can be used in like how you use any other traditional yarn. So nothing else is required to process Kelsen yarn. It will be going through the same textile techniques and same textile process, so to say. So yeah, it can it has variety of. I mean, right now we are talking about just the apparel application here. But the pictures which is on the slide is actually from our product. So those are the knitted and the woven fabric from on the product. One question which comes here is that what happens after this? Like, what is like the end of life of this, right? Does it, and how long does it take to dispose of if you need to? Because sustainability, another part of the sustainability is like how do you dispose the end product, right? So we actually, can you go to the next slide, please? We actually did our compostability test, which was through a regenerative waste lab report. So they came with a conclusion that our test sample exhibited a high level of degradation during the period of 61 days. 61-day test on the thermophilic composting sensation. The rating which were given from this test was 4 out of 5, 5 being the best. So that is definitely very promising, and we can proudly say that Kelsen fiber is highly compostable in 61 days timeline. And this little video which you're seeing is showing the process, how it was done in this test. So super impressive in terms of we can understand it will not contribute to the landfills, which is another problem in the textile world. And then just based on like this towards the end of this, we want to definitely highlight some of the awards and recognition which we have got recently. The first one being the Positive Luxury Award, where we won the Material and Manufacturing Innovation of the Year, which was this year in 2023. So this award is given to the material supply or manufacturing business that has demonstrated innovative and anywhere from design, R&D, production, supply chain, and logistic management through the end of the life management. So we won this award this year. Another feather on our cap is the Consider Beyond Award, which is getting an award for conscious brand, and then that was in the category of fashion innovation, which recognizes and empower the world's best brand, making great efforts to the positive impact of our planet and our community as a whole. And one of the recent one, which was a Fast Company, we were one of the finalists of the for the Innovation by Design Award. We were in the category with some of the leading companies, some of the big names in the tech world as well. So we were one of the finalists for this award as well. And to close it all, we made a big market debut with Stella McCartney show a few weeks back in the Paris Fashion Week, and then this fashion show was it was called Stella Sustainable Market, and which featured about 22 stalls of vintage clothes and material innovation startups. So Keel Lab was one of the participants. The goal was to inspire and educate the attendees on the circular fashion and then different yarn alternatives. And this was the first time where the show participant had the opportunity to touch and feel the Kelsen yarn and see that Kelsen is no more a concept. It's a revolution which just got started. So on that note, we would take any questions from the audience, but thank you for your time and your patience.
Thank you so much. Yes, we do actually have quite a few questions from the audience. So I will start at the top and make my way down the list. The first one is focusing on your collection system that you talked about in the beginning of the presentation. So how widespread is the seaweed collection today? Are you focusing just on one region of the world, or are you collecting it from all over?
We are actually focusing on all over. We do not have a region. We have looked at a few areas which definitely looks promising than the other, but overall we are not restricted to any geographic location at this point. We are exploring, and the whole world is open for us.
Are you shipping it from the different sections of the world to one central location? Is it being dried first and then shipped? Like, how do you maintain the integrity of the seaweed?
So we get in different forms. Most of the times we get in the alginate forms, which is already a processed seaweed. And then, we take it further from that here at NC State, at the Morrisville location in North Carolina. So most of the time it's in the powder form, but we have some ongoing research as to how to convert the seaweed into alginate is also in progress.
Yeah, I mean, the people who isolate right now, there's a lot of companies out there that will isolate the sodium alginate from seaweed, and they will either use direct local source, or if it's shipped, it's dried first so that they're shipping a much lower weight material. And a lot of that is done as I said earlier, there's that MG ratio that's an important part of this. By using seaweeds from different locations and different species, you can adjust it.
So actually, following up on that question, there are a few questions about the M and G. Would you want more M than G for desired fiber properties and processability?
That's something that we are looking at. We really, at this point, can't say exactly what the optimum ratio is.
And how do you take into account? Oh, go ahead. Sorry.
But different blend has different properties. So
Yeah.
it depends on what kind of application you're looking into as well.
Okay. There's a second question on that. How do you take into account in the yarn production, since different algae species give different Mg composition, thus different properties?
Go ahead.
So we do like initial preliminary screening of all these alginate and to understand what they how they behave compared to what we have been using. So it is all decided on some of the lab work which goes into a place. We have a lab set up at our location as well, where like research scientists are working on that.
Great. And some questions about the processing. Does the solution that you're using contain any other bio-based materials? I know that you mentioned the alginate was around 45 to 65%. What else is in there? Or is that the secret sauce?
In the seaweed itself? The seaweed itself has a lot of other materials, and there are actually some companies out there that do biorefining from the seaweed, looking at some of those other components that's within there. And as far as our dope, we've got the algae as a major proportion of that. There are other things we put in there that we really can't discuss right now, but the focus is on looking at things that are on the bio-based side.
Yeah, but to your question, on addition to Matt's point, is that we do not use any kind of toxic or hazardous chemicals during the process. Any kind of additives which goes in the dope is very climate gentle.
Yeah, it's both climate and worker safe as well. We look to make sure that we're not exposing anybody to any toxic or noxious chemicals.
Mm-hmm. Where are the yarns produced today? Is it only in the USA? Or are you producing in Asia or anywhere else? Are you planning to expand?
I'll answer that. Right now, we are all producing the yarns in USA. We will decide at some point that what we want to do in terms of when we scale up to that limit. But right now, all the kelson yarn is produced in-house in North Carolina, actually.
Okay. Let's see. How do you dye kelson fiber, or does it mostly stay as that natural color?
It can definitely be dyed. We've looked at sort of done a dye screening, just looking at various dyes we've got a variety of colors we've done. We are leaving most of the dyeing, obviously color, up to the brands that are interested in it. But we've done some simple work just to demonstrate that can be done. Do we have any?
Yeah, I think it's a bit like the end of this. I don't know. Yeah, so we had a picture to show that some of the test results from our dyeing experiment.
How do I get to it?
The last one.
I'm curious if it dyes like a cotton fiber or if it dyes like like you're using reactive dyes or dispersed dyes or acid dyes. Like, how do you dye kelson fiber?
We don't dye kelson fiber. We definitely dye kelson yarn and fabric. We don't. Correction. We do not dye kelson yarn. We are actually dyeing the fabric, which is a blend of kelson yarn and any other yarn in that. And the dyeing happens the same way as you would dye any textile fabric, for that matter. But obviously there are some restrictions, and it's an ongoing study for us to understand. But some of the initial test results have shown really promising results in terms of like dyeing and different kinds of dyeing, and similar to what the industry have been using, nothing out of the ordinary, really.
Okay. Can you elaborate how much seaweed fiber is in the kelson yarn, and what is the lowest yarn count that can be spun?
Well, I can't answer that last part because we don't know. But we've done
various other.
We've done various typical 30 count has been kind of our common go-to one, but we know we can go down from there and up.
That blended with cotton, so that could be like your t-shirt weight yarn.
Yeah.
Okay.
Yeah. So we have done like 30 singles, 30 doubles, 40.
We've done 40 singles.
And then 10 as well, which would be used for weaving. So yeah, different various other like, and it's not restricted to just those yarn count. It can be beyond that.
Yeah. Those are just the general ones that we've looked at so far.
And Textile World uses most of it.
Yeah.
Are you typically selling blended spun yarn, or are you selling a combination of spun and filament yarn?
We have not done a lot in the filament yarn area. We are definitely selling it as a blended yarn.
Yeah, blended spun yarn.
Yeah.
Did you test the washability and durability of the Kelson fabric, maybe using some AATCC test methods?
That is definitely some of our future work is focused on that. We've done some preliminary work, but we haven't done the full true AATCC method yet.
But we do have a copy of it, and we're definitely looking at all these tests more on the durability and wash wear cycle for sure.
Yeah.
Yeah. Things like shrinkage, color fastness when you get to that, abrasion resistance, so that's ASTM. Since your yarn is based on polysaccharide, it is very susceptible to microbial growth, such as bacteria or fungi. If so, how do you prevent it?
Well, it's right now, as you saw, it definitely is susceptible to certain microbes. Otherwise, it wouldn't compost as well as, as it did. And we right now are not doing anything in particular. We have not done a long-term shelf life on it to see how susceptible it is under non-composting conditions. Would
you say it's similar to other natural fibers like cotton?
Would expect that, yes.
How is the hand feel of Kelson fiber? Is it suitable for intimate apparel?
The hand feel, to answer your first question, definitely hand feels is very soft. Yeah. It does not, I mean, when you touch it, it feels like you're touching, I felt like a cloud, I would say. It's very soft and, definitely, something you would connect and you want to wear it for sure. What was the second portion of the question?
Could you use it in intimate apparel?
I mean, we haven't.
You haven't tried that.
Tried it yet, but I don't see why not. Yeah. Right. I mean,
one of the first impressions whenever anybody who's working with this material has always said, "Wow," when they get the feel of the fiber and any fabric we've made from it. So, just sort of as a qualitative, not a quantitative answer to that is people seem to like the hand feel.
And another question from our audience. I read in the literature that seaweed fiber has some inherent flame retardant properties. Thoughts?
Yes, thoughts. We're aware of those properties, but to date we haven't done any formal flame tests on it. There is something that is in our long list of things that need to get done.
Would you look at blending with recycled polyester to spin finer and stronger yarns for lightweight materials? Maybe bio-based polyester fiber.
Yeah, we definitely want to stick with our the bio component, right? So we definitely can be regenerative cotton, bio-based polyester. We have not looked into that area, but we have definitely looked into some of the natural fibers options for sure.
Let's see, this next question. Let me see if I get this right. Fiber tenacity at break of 100% Kelson fiber. Is it similar to cotton, lower, or higher on average? I guess what they're saying is it stronger or weaker than cotton?
It's comparable.
Okay.
Yeah, it is definitely comparable. I mean, it's within that similar standard deviation, and the average numbers are still comparable to cotton.
You're not going to see PET at this point.
No.
Have you had garments produced using 100% Kelson fiber? Was it the Stella McCartney collection? Was that 100%, or is that a blend?
It was a blend. Yeah.
And it looked like they were crocheting it too, so it must have been a very chunky yarn.
For this, yes, I mean, Stella decided to do her way. Well, we did provide her the blended yarn. But yeah, talking about just producing 100%, we can do. It's not unheard of. It does not have to be a chunky yarn to do a crochet. We have developed T-shirts out of it, and pants, and different other accessories. So yeah, it's not just limited. And as we mentioned, right, that we have used different yarn counts for different application as well.
How does seaweed fiber behave in carding? Do you get uniform blending and carding with other fibers?
You seem to. I mean, we haven't had any problems in carding it yet, so.
Yeah, we have not heard anything from the yarn spinners about. They have always given positive, like it's very easy to work with, is what we have heard so far. So all positive, from the yarn spinning side for sure.
So another question up further, what does a brand put on their content label for Kelson fiber? For example, what is the generic fiber that you would list? Is it lyocell? Is it alginate? What do you put?
I think there is a category of alginate fiber. I think there's that category out there. It certainly wouldn't be lyocell. It's not. It's a different product. It's a different base biopolymer than a lyocell. But I think because of some medical applications in the past, there is some category for the alginate fiber, and it could be that. I don't know for sure.
Mm-hmm. How does one get a yarn sample that has the lowest yarn count? I guess we have some interest out there. They want to sample in your yarns already.
I mean, there are different ways to get it. Like, definitely reach out. There's an email address at the end of this presentation where you can reach out, and
it was hello at
keellabs.com, and that will be directed directly to our sales team, and they can take the discussion forward.
Are the mills that you're working with to knit and weave the fabric mostly located in the US, or are you working with mills globally?
We are talking globally. We are talking to we are not just limited to North Carolina or USA.
Or US.
We definitely want to, it depends where our customer is actually. So it's not restricted to just USA.
Okay. And then the last question here, I know you cannot disclose the amount of seaweed fiber in Kelson yarn, but can you say, is it less than 20%, for example? I think you might have said earlier it was between 45 and 65%. Is that right? Or did I mishear that?
That was the amount of alginate in the kelp itself. In our fiber, do we have an official range that we talk about?
Well, we can. I mean, it can. I think the lowest we have done is 25%.
25% the lowest we've done.
And it can go more like 60, 70. I don't know. We haven't tried that far.
We have made 100%.
We have made 100%. Yes.
As far as large scale, I think the higher end is like 70%.
Yeah. So that's the range we are working with right now.
You said that there is water savings in textile production with this fiber. Do you have data on how much or percentile, how much in terms of percentile of water savings?
So this would be like watering for the cotton
Yeah, so
fields
like
and stuff.
talking about LCA mostly.
Yeah.
We have to still go for our LCA. We are in the process of getting an LCA done for our process, but the water saving is basically coming from, as we know, for example, traditional fiber like cotton, a lot of water is used for growing cotton and then processing it, right? For us, there is a big chunk of water saving. Just we don't have to grow seaweed, they grow in the water naturally, right? So that's kind of a big percent of water saving. Processability wise, it's fairly small in terms of what we have, but we do not have a number to report at this point.
Would the kelson fiber be suitable for socks?
Yep.
They feel nice.
We have sleeves and socks, so yes.
How does a kelson fiber compare in cost to cotton?
I haven't really looked at the numbers, and at this point, we're not on the same production scale. So any cost that we look at right now is not going to be realistic in the long term.
Mm-hmm.
Can you dope dye the fiber and then blend?
You could definitely dope dye the fiber. So yeah, the answer is yes.
Oh, interesting. It looks like, let me see if I've got all the questions. There were so many in here. Have you done any wet processing of the fiber? I think that also relates to dyeing, but it could be other type of finishes, perhaps. Maybe wicking finishes, softeners, or antimicrobial finishes, anything like that?
And we've used sort of standard spin finishing for the wet spinning process that we use. Have not looked at any large extent at any kind of finishes to bring other physical properties to the fiber. So that just hasn't been done. We haven't had a need for that yet.
Yeah, I mean,
so when that comes up, we will look at it.
Yeah, some of the customers ask for these specifically, and we haven't received anything, but definitely something we want to look into and understand how it behaves in that way as well.
Is the kelson fiber naturally hydrophobic or hydrophilic?
It's going to be hydrophilic. I just want to make sure I got the right ending on that.
So it acts like a cotton fiber, like a natural fiber.
Yeah.
Have you also done, you mentioned the life cycle analysis. Have you also done HIG MSI analysis of the fiber, which is your material sustainability index to measure sustainability of it?
Not yet.
Yeah.
You have? Okay.
No.
Oh, no, you have not.
In process?
Yeah, I just mentioned not yet, but okay. we are already talking about a different kind of certification for our yarn. So yeah, that's an ongoing, and it's a long list of things we definitely want to do, and we are focused on that.
Yes, I'm sure a lot of brands are asking you these questions when you have sustainability claims on a bio-based fiber. They want to have all the documentation ready to go to present to their customers. Right. I think that might be it. Are there any additional questions from the audience? Anything that you're dying to ask our guests? I think that's it.
Excellent.
All right. Well, I want to thank you guys so much for coming today to present at our Material Interest Group session. We typically have webinars like this twice a year. So for all the members in AATCC who are interested in joining, sign up on the website for other interesting topics like this. And also reach out if there are fiber suppliers, yarn suppliers, or textile suppliers that you're interested in hearing from. You can reach out to myself or Maria at AATCC. So thank you so much, Anu and Matt, for joining us today. And We want to thank you and have a great day.
Well, thank
You're
you,
welcome.
and it was nice meeting the whole group
Yeah.
and you, Christina, specifically. So thank you for inviting us.
And thank you
All right.
for all your great questions.
Yep.
Very technical questions. Now, if they want to reach out to you, it's hello@keellabs.com. Am I right?
That's correct.
So that's a generic email, but it will be forwarded to the respective parties, whoever is the interested party in that. So that will channel to us if there's any technical question for that matter.
Great. Thank you very much. Bye, everyone.
Thank you.
Bye.
Thank you, Christina.
Thank you, Maria.